All right, today we're going to talk about solving radical equations, and that's really what everything we do in the chapters kind of leads us up to, is solving equations. That's what Algebra 2 is all about, solving equations that are higher orders than linear. So a radical equation is simply an equation where there is a variable underneath the radical. For instance, the square root of 2x minus 3 equals 5. And your steps will always be the same. You will first isolate the radical, and then you will square both sides to get rid of the radical. So in this case, the left side, which is the radical, is already isolated, is the only thing on that side of the equation. So all we have to do is square both sides and then solve for x. Now there is an additional step that you always must think about when you are solving radical equations. Remember, you cannot have a negative underneath the radical. So you always have to plug your answer back in to make sure that you don't get what is called an extraneous solution, which is a solution that doesn't make sense. So if I take that 14 and plug it back into my original equation, I get the square root of 25 is 5, which is correct. So that one works. Here's another example. Now remember, your first step is to isolate the radical. So in this case, I'm going to have to subtract 3 first. Now that the radical is isolated, I get to square both sides and then solve for x. I get x equals 82. I can't forget that I have to check my solution to make sure I don't have an extraneous solution. So I'll plug it back in. I get 3 plus the square root of 81 is 12. 3 plus 9 is 12. That checks out. All right, here's another one. The square root of x squared minus 9 equals x plus 1. So now my radical is already isolated, so I simply have to square both sides. Remember, when you square the right side, it's x plus 1 squared. So it's x plus 1 times x plus 1. So you'll have to FOIL that out. And now that you have that, your x squareds will cancel out. And you'll have, if you subtract the positive 1 over, you'll have negative 10 equals 2x. And you'll get x equals negative 5. Again, you have to check your solution, so you'll plug it back into your equation, and you'll simplify. And you end up getting 4 equals negative 4. Well, that is a false statement. So therefore, your actual answer is no solution. Let's take a look at another example. Here you have x equals the square root of x plus 2. Your radical is not isolated, so you have to subtract 2 from both sides. Now that your radical is isolated, you're going to square both sides, not forgetting to FOIL or double distribute the left-hand side. And then now you're going to simplify. So you're going to simplify this by subtracting the x, and now you have a quadratic equation. So remember, back from the chapter in quadratics, there are lots of different ways that we can solve a quadratic equation. We can solve it by factoring, we could solve it by the quadratic formula, and so on. In this case, this looks like it's factorable, so I would choose to solve it by factoring, and I think you're going to see most of these will be factorable. And you'll get x minus 4, x minus 1 equals 0. So in this case, you'll have two solutions, x equals 4 or x equals 1. You will have to check both solutions. And when you plug in 1, you will find that that does not work. So you have only one answer, x equals 4. Now on a test or a quiz, I'm going to want to see both answers, and then I'm going to want to see the one that you are kind of throwing out with just a single line through it, and then what answer you are accepting. So this means that x equals 1 is what's called an extraneous solution. It's a solution that works out mathematically, but then when you plug it in, it doesn't work. All right, let's try another one. My radical is not isolated, so I need to isolate the radical. So in this case, however, isolating the radical would have made me have fractions on my right-hand side. So in this case, instead of creating fractions, it actually is a little bit of an exception to that rule, where I think it would just be easier to square both sides so that I don't have to deal with fractions. So if I square the left side, I'm just going to get 4 times x plus 5. And of course, if I square the right side, I'll get x squared plus 4x plus 4. So there are sometimes, not often, but sometimes an exception to that rule of isolating the radical. Now you're going to distribute and combine all your like terms. Your 4x's will cancel out. And if you subtract the 20, or actually you're subtracting the 4, you'll get x squared equals 16. So now once again, you'll get two answers, plus or minus 4. You'll need to check them both. The negative 4 will not work, and so therefore you have just one solution, x equals 4. All right, now this is an interesting one because I have a radical underneath the radical. But the process still really remains the same. The radical on the right side is isolated, so I can square both sides. But now I have still an equation that has a radical. So once again, I'm going to kind of go back to the beginning. I'm going to isolate my radical by adding the 6. And now I'm going to square both sides again and then solve for x. I need to go ahead and plug that back in to make sure it works. Now, this is an unusual situation. Now I have two radicals. So how do I deal with this? So you're always going to isolate the more complicated radical. So I would look at this and I would say the square root of x plus 9 is a little bit more complicated than the square root of x. So I would try and isolate that radical. Now that I've isolated the more complicated radical, I'm going to square both sides. So now you have to be careful when you square this, because this is the square root of x plus 1 times the square root of x plus 1, which will give you x plus 2 times the square root of x plus 1. Now, once again, you're going to combine all of your like terms, and you're going to get 2 square root of x equals 8. You're going to isolate your radical and then square again. So you're going to get x equals 16. Once again, you have to remember that you have to plug it in to make sure that it works. All right, now this is still a radical equation. It happens to be a cube root instead of a square root. The process is still going to be very similar. You still have to isolate your radical. You're going to raise both sides to the third power now instead of squaring them. And then you're going to solve for x. But now you really don't have to check your solution because you are not going to get an extraneous solution. Not a bad idea to check your solution to make sure you didn't make a mistake, but it's not as necessary as with the square root equations.